All right, so are you ready to explore something pretty amazing with me today? We're going deep with this SciTech Daily article called Earth's Ice Caps Exist Due to a Lucky Coincidence and They Might Not Last.
Wow.
It's based on a study from Science Advances that really changes how we think about Earth's climate history.
It really does make you wonder, why does Earth have these massive ice caps
Right.
when it's been so much warmer for most of its history?
It's a question scientists have been trying to figure out for a long time.
Yeah.
And this new study uses this sophisticated 3D model
Oh, wow.
of Earth's evolution to test out the different theories.
Okay.
And the results are kind of surprising.
Yeah, what did they find?
Well, it wasn't just the planet gradually cooling down over time.
It wasn't.
No.
Hmm.
It seems more like a perfect storm
Oh,
of conditions all coming together at the same time.
interesting.
The researchers actually call it the rare earth for ice phenomenon.
Rare earth for ice.
Yeah.
What makes it so rare?
Well, they found three key factors that had to line up perfectly for
Yeah.
Earth to cool down and develop those ice caps.
Uh-huh.
And these factors weren't really the norm for our planet.
So what were they?
First, you had to have low volcanic activity.
Okay, fewer volcanoes equals less CO2.
Right.
Less heat trapped in the atmosphere.
Exactly.
But how much are you talking here? How much of a difference did that make?
Well, imagine Earth is like a giant oven,
Okay.
and volcanoes are like the heating elements.
Uh-huh.
When they're on high, the planet gets hotter.
Yeah.
But during these icehouse periods, the volcanic heat was way down,
Oh, wow.
allowing Earth to cool significantly.
So less internal heat gave Earth a chance to cool down.
Yeah.
What else had to happen to,
Yeah, to tip the scales.
tip the scales towards an ice age?
Well, the second thing was the position of the continents.
Okay.
During these periods, they were spread out,
Uh-huh.
which led to more rainfall.
Now, what does rain have to do with ice caps?
I'm a little curious myself.
It's all about this process called chemical weathering.
Okay.
So think of mountains as like giant rock sponges.
Right.
When rain falls on them, it reacts with the rock,
Uh-huh.
absorbs CO2 from the atmosphere.
Like a sponge.
Yeah.
Soaking up water.
Exactly. So with the continents spread out, you have more of these rock sponges
Right.
exposed to rain,
Okay.
leading to more CO2 removal and a cooler planet.
So low volcanic activity sets the stage.
Yeah.
And spread out continents act like these giant air purifiers, scrubbing that CO2 from the atmosphere.
Interesting.
What's the final piece of this puzzle?
Well, the third factor was big mountains. Mountains enhance both rainfall and that chemical weathering process.
So it's like a chain reaction.
Yeah.
Mountains lead to more rain,
Uh-huh.
more CO2 removal,
Right.
and an even cooler planet.
That's incredible.
And the researchers really emphasize how unique this combination of factors is.
Oh, yeah?
It wasn't a given that Earth would develop ice caps.
Mm-hmm.
It really was a remarkable convergence of events.
Which raises the question,
Yeah.
what happens if they change?
Yeah, what happens if even one of those factors changes?
Especially when we factor in the impact humans are having on the climate.
Exactly. And that's what we'll dive into next time.
Okay.
We'll explore what this discovery means for the future of Earth's climate and what it tells us about the impact of human activities.
Sounds good.
So last time we were talking about this study suggesting that Earth's ice caps are more like a lucky anomaly than the norm.
Yeah,
It makes you think.
absolutely.
We just assume that the Earth's climate is this is it.
Yeah, we take it for granted,
Yeah.
assuming it's like the default.
Right.
But it's way more delicate
Yeah.
and interconnected than we think.
And if these specific conditions had to come together for Earth to develop ice caps,
Right.
it makes you wonder
Yeah.
what would happen if even one of those factors changed.
Yeah, that's where things get interesting.
Right.
And maybe a bit unnerving, too.
Especially when we think about the impact humans are having
Right.
on the climate. I
Yeah.
mean, we've been pumping CO2 into the atmosphere at an unprecedented rate.
That's true.
What happens if we push the climate system too far?
Yeah, that's the question, isn't it?
Out of its current state?
Yeah.
I mean, we assume that Earth will always self-correct.
We do.
Right.
It's kind of like a given.
Yeah, and go back to a cooler state.
Right.
But this research really makes you question that.
Yeah, it throws some doubt on that assumption.
So even if we stopped all emissions tomorrow, there's no guarantee that the planet would just bounce back
Exactly.
to the climate we're used to.
Yeah, they're basically saying don't assume that Earth will always regulate itself
Right.
back to how it's been recently.
That's a bit of a wake-up call.
Yeah, it is.
Especially since we know that even small changes in global temperature can have huge impacts.
They can.
On every.
Yeah, sea levels to weather patterns,
Yeah.
the whole 9 yards.
So how does this knowledge actually change our approach
Yeah, that's a good
to
question.
climate change?
How do we use this information?
Yeah, I mean, it's one thing to understand the science.
Right.
But what do we do with it?
Well, for one thing, it changes what we think of as normal
Okay.
when it comes to climate.
Mm-hmm.
We can't assume this stable climate
Right.
that we've had for the last few thousand years
Yeah.
is how it's always been or always will be.
It's almost like finding out that the ground you're standing on
Yeah.
isn't as solid as you thought.
That's a great analogy.
And it shows how interconnected Earth's systems are.
Absolutely.
We can't just look at climate change as like this separate issue.
Right. It's all linked
Yeah.
to biodiversity loss, to ocean acidification.
So it's not just about reducing emissions.
It's not.
It's about understanding how all these pieces fit together.
Right.
And finding solutions that address the whole system.
A more holistic approach.
Right.
And a shift in mindset, too.
Okay.
We can't just think we can control nature.
Right.
We got to work with it.
Collaborate.
Yeah, recognize its limits.
Work within those boundaries.
Exactly.
That makes sense, but it sounds pretty daunting.
It is a big challenge.
Where do we even begin?
Yeah, where do we start?
With a challenge this big.
Well, that's a question we'll explore in the last part
Okay.
of our deep dive.
Uh-huh.
We'll look at some solutions,
Okay.
individual and collective.
Sounds good. So welcome back. In the first two parts of this deep dive, we talked about how Earth's ice caps are actually more like a delicate balancing act.
Right.
A rare phenomenon that might not be as permanent as we thought.
Yeah, it really makes you wonder what we can do about it.
Right.
Like, how do we address something so complex?
Yeah. Knowing that our planet has spent more time ice-free
Right.
than with ice caps.
Uh-huh.
It's a bit unnerving. It makes you think,
Yeah.
if Earth naturally leans toward a warmer climate,
Right.
are we just fighting an uphill battle?
It's definitely a challenge.
Yeah.
But it's not impossible. You know, knowing that Earth's climate system
Right.
is sensitive
Yeah.
just means we need to be more proactive
Okay.
in our approach to climate action.
So what does that look like?
Well, first we got to transition away from fossil fuels,
Okay.
like invest in renewables.
Solar, wind, geothermal.
Yeah, all of that.
And we are seeing some progress there.
We are.
More and more countries are setting those ambitious targets.
That's true.
What else can we do?
Well, it's not just about energy production.
Right?
We have to rethink how we use energy
Oh.
across the board.
Like what?
Building energy-efficient homes and businesses,
Okay.
switching to electric transportation,
Uh-huh.
sustainable agriculture.
Sounds like a complete overhaul.
In a way, yeah. But it's not about starting over.
Okay.
It's about innovating,
Right.
making our systems more sustainable.
More resilient.
Exactly.
But let's be real. These are huge changes.
They are.
It can feel overwhelming.
Yeah, especially for just one person.
Right. What can I do as like one person?
A lot of people feel that way.
Yeah.
But it's important to remember that individual actions,
Okay.
they add up,
Okay.
like a ripple effect.
So those everyday choices,
Yeah.
like using energy-efficient appliances,
Right.
reducing our car use,
I am.
supporting sustainable businesses,
Exactly.
those things actually matter.
They do. They really do. And they send a message policymakers,
Uh-huh.
corporations.
That people want change.
Exactly. Voting with your wallet.
Right.
And beyond individual choices.
Yeah.
There's a collective action.
Like what?
Getting involved in your community.
Okay.
Advocating for policy changes.
Uh-huh.
Supporting organizations. Working on climate solutions.
Right. So using our voices, our collective power to push for a better future.
Exactly. And this deep dive,
Right.
understanding Earth's climate history,
Yeah.
it gives us a new perspective.
On the urgency of it all.
Right. We're not just trying to fix a problem.
Right.
We're trying to make sure there's a future.
This deep dive has really opened my eyes.
It's a remarkable story.
It is. Who knew ice caps could be so precarious?
It shows how interconnected everything is.
Yeah. We're all part of that web.
We are.
And our actions have consequences.
So for everyone listening out there,
Yeah.
even though our planet might naturally be warmer,
Right.
we can still save our future.
We have the knowledge,
We do.
the tools,
Uh-huh.
the power to create a more sustainable world.
It's up to us.
So thank you for taking this deep dive with us. We hope you learned something new
Yeah,
and that you feel empowered to make a difference.
absolutely.
Until next time, keep exploring, keep questioning, and keep pushing for a better future.